Well, this is an inconvenience. Somebody has decided to lay down in my camera's view right as I was getting ready to go over the answers to Math Minute number 35. I don't think she realizes how inconvenient she is, but she might be just a little right at the moment. So oh, yep, there's the tail. I'm gonna stick it over here and I'm gonna move my camera and hope that y'all can see it. Despite the large furry object in the way. Here we go. The number 435 should be written as 435. In cases where the tens and the ones are written out, they are always separated by a hyphen. So it's going to be C, 435. Excuse me. 435 would be 400, would look something like this, 435. I don't know if it's 35 hundredths or 35 thousandths or what have you, but and always indicates a decimal point. So we know it can't be A. Number 2, which set of shapes shows two figures that are not congruent? So they are not the same size and shape. It just so happens that she has it uncovered. It is, it is D, because you can see this is a right triangle and this is more of an elongated triangle. This one, these are both rhombi, even though one is turned vertically. These are both the same size and shape, and these are both the same size and shape as well. Okay, so number 3, 1/4 or 75%, and we're looking for the larger amount. 1/4 is equal to 25%. These are what we call benchmark fractions, benchmark percents, and benchmark decimals. They're all equivalent to one another. 1 out of 4 quarters is 25%. So in this case, 75% is larger than 1/4. 25% or 1/2. Again, this is 1/4. Or you can say 1/2 is 50%. And so therefore it's a little easier again to compare if you have apples to apples, apples to apples, and then you would see that 1/2 is indeed the larger quantity. 25% is less than 1/2. Then we have 9/10 or 95%. If you get 9 out of 10 correct on a math test, like this Math Minute quiz that you'll have this Friday, it's a 90%. So 90% or 95%. 95% is larger in value than 90%. However, they're both A's, just so you know. Number 6, the following cards were numbered as shown, placed face down on a table, and then mixed up. If a card is turned over randomly, what number would show up most often? So before I actually do this particular problem, I want to remind you that the mode is what they're looking for. The mode is the number that occurs most often and specifically in a data set. So now this isn't technically a data set, right? Maybe it is and we just don't know it. But I want to continue to try and remind you of these things that will pop up again in 6th grade and potentially briefly were viewed in 5th grade. So in this case, which number is the one that will pop up the most? And that is 8. Because I have 1 8 here, and I have another 8 here. Okay, I have 4 times 9, which is 36. And I have 6 times some known number is 36. I need to find the secret identity of this variable x. And in order to do so, if I'm multiplying 6 times x, I'm going to divide both sides by 6. Remember, I have to do both sides by the same number because I'm keeping it balanced. We don't want one side to become extremely unbalanced. And 36 divided by 6 is 6. So if I fill in this box, I'm going to just double check. 6 times 6 is 36. and they are indeed equal. And again, if we were writing this algebraically, we would say x is equal to 6. Number 8, which of the following graphs shows these ages the best? Bob is 12. So I'm going to say that I'm looking for a graph that goes over the 10 line for Bob. So that would be either A or B. So I can get rid of C. C shows Bob being about 6. Then we have Tim is 11. So again, I have to have one that goes over, but I can see that Bob's should be higher than Tim's. So in this case, Bob's is smaller than Tim's. And in this case, it's taller than Tim's. So it must be B. We don't even have to look at Vern. And in fact, in both of these, they look to be completely accurate. Number 9, we're just practicing our multiplication. 14 times 2 is 28. Because 2 times 10 is 20, and 2 times 4 is 8, so that's 28. 2 times 21 is 42. Again, 2 times 20 is 40, and 2 times 1 is 2, so that's 42. And 30 times 2 is 60. All right, we have, sorry, that got her up really quickly. So we have the same 2 fractions for the bottom 3 problems. We're just changing the operation. So 1/3 times 1/3. I'm going to multiply across my numerators. 1 times 1 is 1. 3 times 3 is 9. When adding and subtracting, I have to make sure that I have a common denominator on the bottom. And therefore, the answer will have that same common denominator. And now I just do across the top. So I'm going to add across the top here. 1 plus 1 is 2. And I'm going to subtract across the top here. 1 minus 1 is 0. So my answer here is 0. When you get into, I'm not sure if it's going to be junior high school or if it'll be high school algebra, you will get to understand what it means for a problem to be undefined. And so if you have a 0 on the bottom of a fraction, it is undefined, meaning you can't define it. It's like saying 3 cats divided by 0 people. Well, how do you divide your 3 cats by 0 people? That's undefined. But if I said I have 0 cats divided by 3 people, that means that those 3 people just get nothing. So when it's on in the numerator, it is 0. When the 0 is in the denominator, it means that it is undefined because you cannot divide something by nothing. All right. Enjoy your evening.